right on that prime factorization.
Oh, guess what day it is?
Under prime factorization, we also call this aka product of primes, and aka sometimes I refer to it as the tree thing. Do you remember this? Prime factorization would look like this. If you have 36, there are two different ways to break it down so that it is a product of all prime numbers. In other words, what prime numbers times themselves will give you 36. One of them is the tree. And the tree does this. You make little branches off of it. You split 36 and you say, you can do it any way you want, you'll end up with the same answer. Let's say 36, you say, okay, it's 6 times 6. You can't stop breaking it down until you get to prime numbers for the branches. 6 is not prime, so you can split 6 down into 2 times 3 and 2 times 3. Are those prime numbers? Yes, and you stop. I've had people do this, and this is just kind of silly because it can go on forever. They'll go, oh, 2 is 1 times 2. Well, if you're going to do that, you're going to go on forever because 2 is also 1 times 2. Once you get to a prime number, you must stop, otherwise you'll... And then when you write it out, please write it out in order. I don't know for sure if the book gives it to you like this, or if you want to write it using exponents, 2 to the second power times 3 to the second power. Either one of them in my book right now is okay until I tell you differently. And it wouldn't have mattered if you would have started with 12 times 3 or started with 9 times 4, you'll still end up with those same prime numbers there at the end. So, the other way to do it, and this is maybe a way to do it when there's bigger numbers, if I asked you to prime factorize 500, is to do what we call division by primes. I don't know how many people do this, but it's kind of a... And when you do division by primes, it's just what it says. You take the number, and you always divide it by a prime number. Okay, don't divide this by 100, because 100 is not a prime number. You have to think what prime numbers go into 100. Usually, I try to go by 2s, because cutting things in half is usually pretty easy. If you divide 500 in half, you get 250. 250 is even, so I can cut it in half again and get 125. Now 125 can't be divided in half because it's not even, so you think about your rules of divisibility. 5 goes into it because it ends with a 5. How many times does 5 go into 125? 25 times. 25 can be divided by 5 again. And once you get to a prime number at the top of your division, you can stop. And these are all of your prime numbers that when you multiply together will give you 500. And certainly you could write it as 2 to the second power times 5 to the third power. That'll give you 500. This is the tree thing. This is division by primes. And you can, unless it tells you to do it specifically one way, you can do it any way you want. Maybe another example would be, see if they give us a hard one. Is there a tough one in here anywhere? Actually, I don't see where they give it to us. Oh yeah, they do. They do something like, actually they don't give exponents, they just write it out, but if when you're correcting you can figure it out. Some little pattern that you might see is this. What if I did product of primes of 100, 1,000, and 10,000? When you have one with a bunch of zeros, guess what all of your prime numbers are going to end up being? What do you, well, let's just do it. 100, what times gives you 100? 10 times 10, right? And 10 times 10 is 2 times 5 times 2 times 5, right? So you end up with 2 2s times 2 5s. What gives you 1,000? Anybody? Yes, Mr. Hahn, how about 10 times 100? Now the beauty of this, children, is once you've prime factorized a number, you don't really have to go and do it all over again. I prime factorized 100 already and got this, so I could just say, okay, 100 is 2 times 2 times 5 times 5. No need to reinvent the wheel. What is 10? 2 times 5. So guess what you get? 3 2s times 3 5s. Anybody see and can speculate what 10,000 would give me for the prime factors? It's a leap of faith, if you will. Kate Kunacek says,
2 to the 4th power and 5 to the 4th power.
exactly, however many zeros you have are going to be how many 2s and 5s you have, because 2 times 5 gives you 10. 10 times 10 is 100. 10 times 10 times 10 is that, and 10 times that. So this one's just going to end up being 4 2s and 4 5s. And that, boys and oh, did I do something wrong? I had my 4th time? So a million would be 2 to the 6 times 5 to the 6.
So what was do we have to show it?
No, I would think I would go with that. You just say I'm just that smart. And 5 million, if you're making that deductive leap, is a million times 5. So you know a million is 2 to the 6th power times 5 to the 6th power, but now you have another 5 out there. So it's actually going to be 2 to the 6th power times 5 to the 7th power. Because you got an extra 5. Wow.